Erik Darling here with Darling Data, and it's just me and Bats here kicking it, feeling real twinsy here. Mwah. Love you, Bats. In today's video, we're going to talk about Intel updates. Getting the hell off my screen. Intel. What can Intel get right these days? That's the big question. Anyway, in today's video, we're going to talk about subqueries. Oh dear. Now, in the last video, I did foreshadow this a little bit because we were talking about exists and not exists, and how a lot of people who I end up working with think that exists and not exists are bad because they're subqueries. And they just have this thing against subqueries. They're like, subqueries, oh, they always execute once per row. Oh, they're slow. They're not as good as joins. They have these preconceived notions that certain things are just always true across every query ever, and that they know best and better, and they have some kind of authority in the matter. They've tested every conceivable query that you could ever write with every index and every database, with every cardinality estimation model, and they just know everything is always true the way that they learned it. They're often wrong, and that's what we're going to talk about today. So before we do that, let's talk about money, everyone's favorite subject, unless you ask them how much of it they have, because that's when people get uncomfortable. If you would like to become a channel member, you can do so for as little as $4 a month. It's just a nice way to say thank you for all of the content that I produce. You can do that by clicking in the link in the video description that says, like, become a member. Cool. If you don't feel like giving me $4 a month, you can like, you can comment, you can subscribe, you can make different numbers go up, which also always fills my heart with joy, and makes me feel less alone in the universe. If the things I'm talking about during these videos make you think, wow, that Erik Darling sure is good at SQL Server, you'd be right. And I'm also available for consulting in SQL Server matters like these. And as always, my rates are reasonable. If you would like some very high quality, very low cost SQL Server content that you can buy once and will continue to be yours, and you will have access to it for the rest of your life for about $150 US, you can use you can use the link in the video description, or you can go to that URL right there and put in that discount code, and you can get all 24 hours of my performance tuning training for the one-time low cost of $150. No upcoming events. It is the end of the year. I have no interest. 2025, I will have lots of interest. Anyway, let's talk about subqueries, because they're a lot of fun. So we're going to talk about subqueries in the select list. I like them because you can use them to skip a lot of additional join logic. When you write a join in a query, the optimizer will do all sorts of funny things, wondering about where that join would best be placed in your query plan. It doesn't really do the same thing with subqueries. Now, when people start saying that subqueries run once per row, they are not entirely wrong. But the thing is, if you write a join, that join might also run once per row too. If you write a subquery and SQL Server uses a nested loops join, and let's just say that your query returns 1,000 rows, yes, that subquery will run 1,000 times to produce a result in a nested loops join. If you write a join that does whatever your subquery wants to do, and SQL Server chooses a nested loops join, your query might actually run, your subquery might actually run, or your join might actually run a lot more times, because that join might happen way earlier in the query plan. And let's say, rather than just running 1,000 times at the end, what if it gets joined to a big table and it has to run lots of times? Gosh, this sure do get confusing. So when people say things like subqueries run once per row, well, lots of things can run once per row. It all depends on the type of physical join that the optimizer chooses to implement that semantically correct query logic physically in the query plan. Hash joins and merge joins, they typically do one big seek or scan of an inner table, bring a bunch of data back. Nested loops joins, you know the algorithm. You take a row from the outer input, send it to the nested loop, go do something in the inner input, grab a row here, grab another row, that is also once per row. Ah! Ha ha ha. My rates are reasonable. Anyway, subqueries do have some limitations. There are times when you can't use them, which is okay, because everything's got to have limitations. I have limitations. I don't know anything about Oracle. I don't know anything about cheap wine, except not to buy it. I don't know anything about I don't know what's something else. Let's go on. Anyway, but if you use subqueries in the right way, they can be an excellent method to retrieve some calculation result without worrying about what kind of join you're doing and how the optimizer might try to throw that join into the mix of, let's face it, I know your queries. There are 42 left joins, 11 inner joins, and 13 cross joins already. Throw another join into the mix. Why not? What could get worse, you buffoon? Since subqueries are in the select list, it is sort of like doing an outer join because the subquery is not actually allowed to eliminate any results. It takes however many rows are going to get projected from everything from like the from down, your from, join, where, group by, stuff like that. And it takes that result and it says, sure, for every row that I'm going to get out of all this whole jumble of things that user X just did, I'm going to go run this query to get a result for the row, which could be a nested loops join or it could be not a nested loops join. But either way, it's going to be an outer join because it's not going to filter anything from the results. So the optimizer doesn't have to care as much about where that join gets placed. It's usually going to be way to the left in the query plan because that's the left outer join that's not going to eliminate anything goes because we need to get all the stuff that we're going to actually do stuff for first. So that's good. It's all good, wonderful things about subqueries. And the optimizer is generally smart enough to retrieve data for the select list subqueries after all the other joining and filtering is done, so they can be evaluated for as few rows as possible. There are, of course, bad ways to write queries that might end up with a query plan that contradicts that statement, but I'm not in the business of writing bad queries. I'm in the business of writing good queries that run fast. So the most important thing that you can do as a developer, if you're going to write subqueries, or really almost any kind of query in general, is to make sure you have good supporting indexes for them. So this is where we're going to talk a little bit about performance before we talk about other stuff. Now, I've already created good indexes to support my subqueries. I already have them, but what I want to show you is what a query plan will look like. I'm forcing SQL Server to use the clustered index for each of these three subqueries. What I want to show you is what a query plan will look like when subqueries in the select list are going to be slow. So let's just get an estimated plan for this. And the important thing that I want to show you is over here. If you have a query, we're talking primarily about subqueries in the select list, where you can see this happen. But if you have any query, ever, and you look at the estimated query plan, or you're looking at something from the plan cache or something in Query Store, and you see eager index spools like these, this and this, being built off a large table, like say the post table in the Stack Overflow database, that means that this query is probably going to be a lot slower than you would hope. This query is not going to be in for a good time. SQL Server is using a single thread to scan the post table once there and once where my head is. So it's scanning that twice. It can only use a single thread because it's building an eager index spool here and here. So this isn't actually even going parallel. Sorry, this and this aren't actually even going parallel. Even though they have parallelism operators on them, you can only build an eager index spool with a single thread. This is Microsoft, once again, kicking standard edition users when they're down because they never want you to be able to build an index in parallel. No, nothing for you. So that happens, right? Like this is what a query plan will look like when subqueries are going to be bad. Always keep an eye out for this, no matter what kind of query you're writing. If you see eager index spools being built off large tables, like the post table, you're either missing an index that would really help SQL Server, or the optimizer is making a buffoonish choice, and you need to add in a force secant. Because the optimizer will sometimes build an index spool off a perfectly good index that it could have seeked into. I brought this up to Microsoft, and Microsoft does what it usually does and shrugs and says, oh, sorry, we spent $70 billion on AI. We can't fix basic stuff in SQL Server. So that's cool. Anyway, let's move on. And let me show you, I've quoted out the index hint here. So now SQL Server is going to be free to use the indexes that I have created that are good for our subqueries. And what you'll see is that SQL Server does indeed choose nested loops. So these subqueries do run once per row. That does happen. It do be like that. But you could write any kind of join. You could write apply. You could write cross apply. You could write outer apply. You could write a regular join. You could write a derived join. And SQL Server might choose nested loops for it. In which case, it would run once per row anyway. Gads! I've been gapped. Anyway, if we run this query, and I'm actually going to give, I should turn on query plans. That would help, right? If we run this query, I want you to note that it runs very quickly. We don't spend a long time doing anything in this query. In fact, if we go look at the execution plan, it finishes in 23 milliseconds. This doesn't feel like subqueries being slow to me. This also doesn't feel like there being a very big penalty for 3 subqueries running once per row. We don't really do much of anything in here. It's just this final subquery that does a little bit of extra work. These seeks are very fast. We get zeros in here. It's just this final count one that does any sort of work. We get 22 milliseconds of work across those 2 operators. So that's really not all that awful. All right, this is a fairly quick query. Now, there are times when you have subqueries that have very, very common sub-expressions, right? Like all of these queries are doing something pretty similar. All 3 of them are correlating on the post type ID column, right? But this is looking for post type ID 1. This is looking for post type ID 2. They're all correlating on owner user ID equals user ID. All 3 of them are doing that. And all 3 of them are going to the post table. So there are times when very repetitive subqueries like this can be collapsed into a single apply and can be faster. There absolutely can happen. Not going to BS you on that. But typically that is when the subquery is rather complex. What I see a lot in some client query plans when there's a lot of complexity like this is, let's say that the query runs for 1 second, and let's say there are 100 operators in it, right? In the query plan, 'cause it's a big complex query plan, and I'm running it to get the actual plan, and I start looking at operator times, and there's not really a single part of the plan that really contributes to that 1 second. There are lots and lots of little parts of the plan that all contribute to it taking 1 second. When I see that and I need to make it faster than 1 second, my goal is to reduce the complexity of the plan, which and part of that is reducing repetitive subqueries in the plan, or let's just even go a little further than that. Let's just say collapsing repetitive expressions in the plan. That can be a really useful trick. Okay, so I'm like, there are times when that makes sense to do. This just doesn't happen to be one of them. So if let's say that, you know, like we look at this query and we think, oh, I think that all three of those subqueries are like, you know, we've 23 milliseconds. We need it to be faster. Now, let's say that we wanted this to be quick, and let's say we had a mental problem with making 3 round trips to the post table to do the stuff that we were doing up there. We have 2 ways that we could write that. We could rewrite this query. Right? We could use a derived left join, right? Because remember, subqueries in the select list will always be outer joins because they're not filtering out any rows that qualify to be projected from the query. We want to find what whatever calculation in the subquery. So we could rewrite this as a derived left join. We could get the max for post type ID 1, the max for post type ID 2, and the total count. And we are looking for, of course, where post type ID is in 1 or 2. So we could do this. And this would still be reasonably fast, but it is not 23 milliseconds fast. This is 59 milliseconds. We spend 45 milliseconds seeking into the post table, and then another 14 milliseconds aggregating that data, right? Because 59 minus 45 is 14. And this query ends up being just a little more than twice as slow as the 3 separate subqueries. We could even rewrite this as an outer apply, right, with the exact same logic. Because remember, no cross apply because we're not restricting rows. We're just applying a calculation to the result, right? We can run this, and this gets an identical plan to the derived left join and ends up at 59 milliseconds, right? We get the exact same query and timing from both of those. So in this case, making the 3 separate round trips is about twice as efficient as making a single trip to the table. Now, query rewrites to use specific syntax arrangements are not available in ORMs generally. Many times while working with clients, we'll stumble across really, really awful application-generated queries. We'll look at them. I'll be like, here's a useful rewrite. Look how much faster this goes. We are twice as fast. We are 3 times as fast. We are 10, 100 times, 1,000 times as fast. Look at how much better things could be if you weren't using that ORM. Maybe we could take this query that the ORM is causing problems the way it generates, and maybe we could put that in a store procedure with the way I've rewritten it and make your life easier and better. And they're like, no, it's ORMs only. And I say, okay, well how would you use your ORM to build the query in this way? And I'm like, oh, I don't know, we can't do that. Okay, so your only option is to stick with an ORM that builds an inefficient query, and you're just going to live with that because you're afraid of the store procedures. This happens quite a bit, and I'm like, So what should we do? What should we do here? What would you like me to tell you? How can I get this across to you in a different way? Your ORM is good up to a certain point. These queries have reached the point where it is no longer good. You need a different API into the database. The store procedure is just an API, right? All it is an access layer into the database. You can make this better. You can fix things. We can improve things. All we have to do is get away from these ORMs. Not everything that code produces is good, right? We built a query with code. The query sucks. Maybe the code sucks too. I don't know, but for the most part, people just don't know how to improve that. There's really not a lot of fine-grained control there. It's up to you to rewrite queries with a better arrangement so that they can be faster. Now, in this case, both of the attempts at rewrites resulted in an identical query plan. The optimizer did a fine job here, but both of the single trip queries were a little bit over twice as slow than the original. In this case, the difference is absolutely microscopic, right? It's the difference between like 60 milliseconds and like 20 milliseconds, right? Not anything that we're going to get crazy about, but I just do want you to see that like making those 3 round trips was more efficient than making the single round trip. For me, the real advantage of writing out the 3 separate subqueries is to better understand which of those subqueries does work. It's almost the same thing, and we're going to talk about this more with common table expressions, but it's very, very similar to that pattern where when I see lots of common table expressions being used in a single query, one of the first things that I do is I start just individualizing those common table expressions as select into temp tables, because it helps me figure out exactly which point in the common table expressions I can is really slow or causing problems or causing bad estimations that trickle down to the rest of the common table expressions, and where I can start fixing things. And maybe sometimes the end result is that I need to use the temp tables, and sometimes the end result is that I can make meaningful changes within the common table expressions to make those faster, and we can stick with the original. Now, if, like I was saying earlier, if these subqueries were a lot more complex, excuse me, and they had a lot more going on in them, like we had to find the top one, but then join to something else, and have an exist clause, and we were just doing a whole lot more work in each of these, then I would probably be a little bit more keen on collapsing this stuff into one either derived join or outer apply subquery, or just maybe dumping where is it? Sorry, up here a little bit. Maybe I would just dump this into a temp table with an exists clause. Remember the exists in the last video, with an exists on users, so that I could filter out the size of this and only bring rows in there, and then just join the temp table to the users table and bring that out. Sometimes that can be a good approach too, but it all depends on, well, a lot of local factors. Again, a lot of this stuff does depend on local factors, but anyway. So, subqueries in the select list. Not always the worst choice. Whenever someone says they're row by row, well, it depends on what kind of join SQL Server implements to, or rather what kind of physical join SQL Server implements to logically implement your subquery. If it's nested loops, yes, it's row by row. But you could get row by row from nested loops if you write a join or an apply or anything else. All of these things can use nested loops and also be row by row. So don't let people drag you down with that, because they're idiots and they don't know what they're talking about. Be smart. Say to them, I know what I'm doing. Write the query, show them it's faster, or show them it's not slow, show them it's no different, whatever. But whatever you do, don't let people get away with nonsense. Don't let people get away with their ChatGPT responses to about SQL Server stuff, because it's not always smart. It's not always right. I spend a lot of time with the AIs trying to get something good out of them, and it's really hard. They're abysmal places. Abysmal. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something, and I hope that you will continue to write correlated subqueries, because, gosh darn it, they can be pretty useful. All right, cool. Well, I'm out of here. Goodbye.